Welcome to Study Loop.
This is problem 97 of chapter 7.4 of Vector Mechanics for Engineers, Statics, and Dynamics. So in this problem, there's a cable stretching from A to E. There is a load applied at B, which is 5 kilonewtons, at C, which is also 5 kilonewtons, and at D, which is 10 kilonewtons. The horizontal distance between A and B is 2 meters, B and C is 2 meters, C and D is 3 meters, and D and E is 3 meters. And the vertical distance from A to E is 4 meters. The vertical distance from A to C is 3 meters. And for A, we are calculating the vertical distance between A and B, the distance of B, and the vertical distance from A to D, distance D. And also for B, we are finding the reaction at E. So to start off this problem, we took a snippet we did a free body diagram from A to C. So we applied the reaction forces at A. AY is in the positive Y direction, and AX we put in the negative X direction. So we're going to start off this problem by taking the sum of moments at C, set this equal to 0. And this equals AX times 3. And it's times 3 because the vertical distance between A and C is 3 meters. We're going to subtract AY times 4. And it's going to be times 4 because there is 4 meters in the horizontal direction between A and C. And it's going to plus 5 times 2. This is 5, the load at B, which creates a positive moment in the counterclockwise direction around C, and times 2 meters because there's 2 meters in the horizontal direction between B and C. So when simplifying, get 3AX minus 4AY, and we're going to move the 5 times 2 over to the other side. So it's going to be negative 10. So we're going to go ahead and solve for AX. So just further simplifying, negative 10 plus 4AY. We're going to solve for AX. So it's going to be negative 10 over 3 plus 4 over 3AY. And we're going to need this later. All right, so now we are going to take the whole cable into account to draw a free body diagram from A to E and draw the reaction forces at E. We put EX in the positive X direction and EY in the positive Y direction. I'm going to take the sum of moments around E, set that equal to 0. And that is going to equal AX times 4, because there is 4 meters in the vertical direction between A and E. Subtract AY times 10, because there is 10 meters in the horizontal direction between A and E, plus 5 times 8, and this is the force at B. The force at B creates a positive moment around E because it's in the counterclockwise direction, and it is times 8 because there is 8 meters in the horizontal direction between B and E. We're going to plus 5 times 6. This is the force at C, also creates a positive moment around E, and it is times 6 because there's 6 meters in the horizontal direction between C and E, and then plus 10 for the force at D times 3. And it is times 3 because there is 3 meters in the horizontal direction between D and E. All right, so simplifying, this will equal 4AX minus 10AY, and all of these loads equal 100, and we're going to go ahead and move that to the other side. It's going to be negative 100. So we calculated AX up here, and we're going to go ahead and plug it into this equation we just solved for. So 4 times AX, which we know from above, is 10 over 3 plus 4 over 3 AY minus 10 AY equals negative 100. So distributing the 4 into this equation, we're going to get negative 13.33 plus 5.33 AY minus 10 AY equals negative 100. So we're going to go ahead and solve for AY completely. So AY equals 18.57 kilonewtons. And we're going to be able to solve for AX as well now, because AX, we again know this equation. It's negative 10 over 3 plus 4 over 3 AY, plugging in the AY we just found. So AX is 21.43 kilonewtons. All right, and because we know the reaction forces at A now, we can go ahead and solve for the reaction forces at E. So we're going to take the sum of the forces in the x direction and set that equal to 0. We know AX is going in the negative x direction, so it will equal negative AX plus EX, because we know EX is in the positive x direction. All right, so we can plug in the value we just obtained for AX, which is 21 plus 43.43 plus EX equal to 0. So EX equals 21.43 kilonewtons. All right, so now we can go ahead and solve for the sum of forces in the y direction, set that equal to 0. So we have positive AY plus EY minus all the loads because they're in the negative direction. So simplifying is 18.57 plus EY minus 20 equal to 0. So we can go ahead and solve for EY, which equals 1.43 kilonewtons. All right, and now that we have obtained the reaction forces at E, we can go ahead and solve for the total reaction at E. This is part B, but I feel like it fits better here because we already are at this point and we have both the reaction forces. So to get the total reaction at E, I'm going to take the square root of EX squared plus EY squared. And plugging in those values we just obtained here and here, the total reaction at E equals 21.5 kilonewtons. Also, we need to figure out theta E, so we just know what direction that reaction force is going. And this is the inverse tangent of EY over EX. Plugging in those values. Make sure your calculator is in degrees. This equals 3.8 degrees in the first quadrant, which is important. Okay, so again, these are your two answers for B. And now we can go back to solving and finishing A. So we're going to do a free body diagram from just A to B in order to calculate the dB. So we're going to take the sum of moments around B, set it equal to 0. And this will equal AY times 2, because there's 2 meters in the horizontal direction between A and B, minus AX times dB, which is what we're trying to solve for. Go to 0. So AY is 18.57 times 2 minus AX, which is 21.43 dB. Go to 0. So solving for dB, it will equal 1.73 meters. So that's one answer for A. And lastly, we're going to do a free body diagram from just D to E. We're going to take the moments around D. Set that equal to 0. And that'll equal EY times 3, because there's 3 meters in the horizontal direction between D and E, minus EX times DD, the distance of D, minus 4. So this will simplify to 1.43 times 3 minus EX, well, we know EX. EX equals 21.43 times DD, distance of D, minus 4, equal to 0. So we're going to go ahead and solve for distance of D. And this would total 4.20 meters. And this is your final answer for A. These two answers are for A. So the distance of B equals 1.73 meters, and the distance of D equals 4.2 meters. Answer for A, and for the answer for B, the total reaction of E is 21.5 kilonewtons, and the theta E is 3.8 degrees in the first quadrant. And this is the problem, or the answer for problem 97.